Welcome to Statistics. I am your teacher, Mr. Lorenz. This is Unit 1, Lesson 1, Basics and Histograms. We are going to start things off with a type of statistical graph called a stem plot. What a stem plot does is it takes a particular data value, like 68, and splits it into two parts, the stem and the leaf. The leaf is the rightmost digit, and the stem is the leftmost digit or digits, depending on how large the number is. A number like 158 would have two digits in its stem, where a number like 38 only has one. The leaf is always a single digit, the rightmost digit. Below you see an example of a stem and leaf plot. Every one of these leaves represents a different data value. For instance, this leaf right here has a stem of 8, meaning that this represents the number 89, which would be one of our data values. The benefits of a stem and leaf plot are that they order the data in numeric order, and something we're going to get into later is they begin to show you the shape of your data. In statistics, I really like to use real-life data, so I'm going to use a data collection activity that I've done in previous years. To collect this data, we had groups of two trying to flip a penny. They needed to record how long it took them to flip 4 straight heads or tails in a row. Here are the results. Now, using this data, we are going to create our very own stem plot. To start, we need to create the border. The left column will be for the stems, and the right column will be for the leaves. I like to leave room for a rough draft and then a final draft, and you'll see why in a minute. It looks like my smallest data value is 12, so the smallest stem that I need is 1. The largest data value looks like this 120, so that means I need stems all the way from 1 to 12. And now I'm just going to go one data value at a time and create the leaves. 20 would go in the 2 stem with a 0 for the leaf. 45 would go in the 4 stem with a 5 leaf. Now 21 is back in that 2 stem, and I'm just going to put a 1 right next to that 0. Now I'm going to go fill in some more, and I'll stop when I get to important ones. Now notice, every time I add a leaf, I'm highlighting the data value so I know I've counted it. Now here's one worth talking about. 61. I'm going to throw the 1 down here, even though that makes this set of leaves not numeric order. That's okay, we'll fix that in the final draft. Here's another important one, 20. We already did 20, but that's okay, we'll just write another 0 there. All right, now our last one, 120. Remember, the 0 is the leaf, and everything to the left, that's the stem. So 12 is our stem and 0 is the leaf. Now we've finished our rough draft of the stem and leaf plot. Notice that some of the stems are empty. That's okay. That's what we call a gap in statistics. We don't want to get rid of those stems, we want to show that they're empty. So now off to the right, I'm going to make a final draft. On Notability, I'm just going to copy and paste. This first stem was out of order, so we want to rearrange it so it goes 2, 3, 8. Now, for future stems, we want to make sure that any number lines up with the number directly above it. So this 2 stem is not good. I want to rearrange these numbers. So I have 3 zeros to start, and notice I'm going to put these 3 zeros directly below the 3 numbers from the previous stem. And now I have 1, 8, and 8, and I want to space them similarly to how I space the other numbers. Nothing to do here with the 3 stem, nothing to do here with the 4 stem or the 5 stem. Now the 6 stem needs to get rearranged again. We're going to do our best to arrange it with the previous stems from up above. So these numbers should go 1, 1, 2, 5. Now this next stem's pretty close if I just switch this 6 and 9, and that all still looks pretty lined up. And each of the remaining stems are all okay. So this would be our final stem and leaf. The reason we want this nicely organized is the things that we will use a stem plot for. We will use the fact that it's arranged in numeric order for things like finding the median, and we will use the fact that it's arranged nicely to be able to determine the shape of the graph, which we'll talk more about in future lessons. Our next conversation is going to be about quantitative and qualitative data. Quantitative data is numbers that represent a count or a measure, while qualitative data is names or labels that have no measure or count. Let's do a few quick examples to understand this difference. If we're talking about an NBA player's team name, that is a name or a label, making that qualitative data. If we're talking about a player's points per game scored, that is a number that represents a count or a measure. That is quantitative. If we talk about a player's jersey number, that is not counting or measuring anything. So even though it's a number, it's really more of a label, making this qualitative. One of the reasons we need to know about quantitative and qualitative data is because it's used to determine whether or not you're doing a histogram or a bar graph. These two types of graphs are very similar to each other. They look almost the same. They each have what we call a class on the x-axis and a frequency on the y-axis, maybe looking something like this. For a histogram, these classes represent numbers, quantitative data. For a bar graph, these classes would represent more labels, such as red, blue, green. In either type of graph, frequency means the same thing. How many items are in each class? This A class would have 1 item, this B class 2 items, and this C class 3 items. Let's take a look back at that data we collected earlier and decide what kind of graph we would use to graph it. First, we have to ask ourselves, is it quantitative or qualitative data? Well, everything we see here is numbers, so that's a good indication of what we're dealing with. And remember what it represented. It was how long it took to flip 4 straight heads or tails. That is a time. Time is something we measure. This is quantitative data. Well, if it's quantitative, we should be using a histogram because it's going to represent a range of numbers. If it were qualitative, we would have used a bar graph. Now let's move on to constructing the graph. We're going to start off with our axes. And for histogram, I like to keep it to somewhere between 5 and 10 classes. And we've got a few too many classes here. So what I'm going to do is I'm going to combine the stems and make each one of those into a class. So my first class would go from 10 all the way up to the top of the 20 class, so 29. My next class would go from 30 all the way to the top of the 4 class, 49. Now, once you get your classes going, you can kind of tell a trick. This number is always going to go up by 20, and this number is always going to go up by 20. That 20 number isn't always going to be the same, but once you figure out what the number is, it's always going to be a consistent growth throughout the classes. So I know we're going to have 50, 70, 90, 110, and 69, 89, 109, 129. And then all we're going to do is count up how many items are in each class. So this class has 9. This class only has 1. This class has 4. This class has 5. This class only has 1. Same with this last class. So on our axes, we're going to mark off these different numbers. I need to get up to at least 9 for my frequency, which I do there. And I'm going to have to make room for all these classes on the x-axis. Now for labeling the x-axis, we usually just use all of the lower class limits. Notice that I included one extra would-be lower class limit because I don't want to just suddenly start using the upper class limit. I want to stay consistent. But I do need to show that there's one more class here. And now we're just going to create bars the height of the frequency. So the first class had a frequency of 9, so I draw a bar at that height. And I'll do the same thing for each of the other classes. And now just adding a little bit of a label to each of the axes, I have my final histogram. Now, so we get a little bit of practice with a bar graph, let's assume we asked a group of 14 kids what would they most prefer to watch on TV right now. And these were our results. Well, even though these are numbers, the responses were all labels. 6 kids answered sports. 2 kids answered reality TV. These are the classes. This is the frequency. Since the classes are qualitative, we would use a bar graph. And the construction would be really similar. Set up your axes, add the classes to the x-axis, make sure the frequency went up to the highest number, and then just create bars at that height. And this would be a bar graph. Now, we're not going to spend long talking about mean, median, and mode, as you've definitely learned this before in previous math classes, but make sure you look over these notes, and I will show you really quick how the calculator can help us. I want you to make sure you have the Desmos graphing calculator installed on your iPad. Now, using this app, it's really easy to find things like mean, median, and mode. I'm going to start by adding a table, and then I'm going to put all of my data in the X1 column. Now, once I have all that data put in, I'm going to go to a new row. I'm going to click on Functions, Stats, and then I'm going to select Mean. And I'm going to type in, this was the X1 column, so I'm going to type in X1. And there's our mean. Now, we can actually do the same thing for median, although there are other techniques. You could arrange the data in numeric order and figure out the middle number, but this calculator does do the median as well. You go to the same place, click on Stats, click on Median, and type in X1, and tells you the median 79. This will not do mode for you, so you need to understand that mode represents just the data that reoccurs the most often. It would help to have this in numeric order, but this data set's small enough for me to see that 72 is the only number that repeats, so that must be the mode. To wrap this lesson up, let's summarize a couple of the key points. Stem plots help us organize data to see shape and have numeric order. Histograms are for quantitative data and bar graphs are for qualitative data. Otherwise, they're pretty much the same. If you came away with anything else for this lesson, write that down now. Otherwise, we'll see you next time.